Cool. Okay, so let's kick it off and we will have people join as they join. Welcome to the Kong Community Call. It's January 8th. And this week we are going to have a demo of Kong Service Mesh on Kubernetes. So if you remember last time we demoed Service Mesh in a local environment. Basically the demo had services talking to other services all on someone's computer. And so this time around, we're going to have Colin show us what it's like to run Service Mesh on Kubernetes. Oh, Hisham, I put you down as presenting, but I believe it's Aapo who's also here to field questions about the settings that we added in Kong 1.0 and basically how those settings work, the nitty gritty of them all. So Aapo, I know that if you're around to answer questions, that's really lovely. I see you're here. And before we kick that off, I just wanted to mention that we're always looking for new speakers. So we have a community speaker set up for next time who's going to talk about mock APIs and proxying mock APIs with Kong. And if you're interested in speaking on the call, please let me know. We're always looking for people, and we've heard about Service Mesh a couple times now, so we're excited for new topics. Great, so with that, Colin, do you want to introduce yourself and tell us a little bit about what you're going to show us today? I think you're muted. Hi.
Yeah, I was. So yeah, I'm Colin. I kind of work at Kong, worked at Kong for quite a while, since before it was Mashape. Do internal tooling, which kind of means that I help, developers be happy, help build tools exist, try to take care and keep on top of the various ways to deploy and configure Kong. And yeah, so today going to demo, let's see. Where's the screen share button?
Should be somewhere near the bottom of your Zoom window. It's a green one. It's got like a little up arrow.
Yeah, Zoom on Ubuntu doesn't show a preview, so I
am looking at your screen.
So is that the entire screen or just what looks like an editor?
I see an editor and I see a terminal.
Okay, cool. So before anyone asks, this is Eclipse Chi, and I cannot increase the font size, and I apologize for that. So this repository is public. It does exist, so people can look through it and walk through it. I have a few changes that I haven't pushed up. So for this demo, we're just using Minikube locally. VM driver is none. Posterity, currently nothing is running in Kubernetes. I'm pretty sure I already built that Docker image. Yeah, I did. So I'll talk through this as I do it. So what I'm doing here is using also a public repository. It's Kong dist Kubernetes. I'm using the Kong 1.0 branch to run Postgres. I'm running the Kong migrations, and then I'm running Kong instance itself. So if we do kubectl get all, eventually all of this should become running. So yeah, so migrations ran, and admin proxy, admin SSL, yada. I'll explain in a second why we need a regular Kong as well as. So I'm going to run something locally called service B. And service B, we'll just wrap that in a watch. By the time I did it, it's already running. So service B, the container I want to see is the Kong container. Cool. So Kong's running, just humming away. So what is service B? So service B, we wait for Postgres before we start, double check my Kong migrations, and I set up the network. We'll circle back to that. So the two things I'm running, so here is the Kong instance. So this Kong instance is configured for transparent proxying on port 7000. And this NCAT is simply listening on port 88. So now that that's running, we're going to run service A. So service A is again, we're waiting for Postgres. We're running an NCAT. We'll attempt to talk to service B on port 8080. And we're running Kong on port 7000 transparently. So container, and we're configuring Kong. Right. So the container in both of them, this one, Istio proxy init. This is rewriting the IP tables on the pod so that all traffic, with the exception of traffic that runs as user ID 1337, of course. So all traffic goes to the Kong container. So transparently via IP table rules, this NCAT via this IP table rule will go to this Kong. So all this NCAT is doing is just echoing date, just piping date through to service B. So if I go back to logs for Kong, cool. So it's working. Demo gods did not strike. So I can tell it's working because Kong is logging that something connected to it and sent traffic through. And I can prove that's working. So if I do the logs for service B, then you can see service A talking transparently through Kong to service B. And then I guess the only thing I didn't show was just the Kong config. This is all of it. So because we don't have declarative config, I'm just using HTTP and this an entry point. Just check that Kong is alive. And then I put these two rules. So for those that were on the last call, this is basically taking an example that Aapo did and just translating it to Kubernetes in Minikube. And so I think that covers the meat of transparent proxying via Kong.
Cool. So can you talk a little bit, Colin, about how this would change in production? Because we've seen a lot of local demos of Service Mesh, but obviously most people won't be running it locally. So, could you point out maybe some places where this would be different, or you might configure things differently, or set up security considerations, stuff like that?
So one way it will change in production is the initial bootstrapping. So right now, so if you want to run a transparent Kong mesh proxy, then you would have to, kind of splice in all of this stuff. And so like, let's say this is your actual microservice or service that you're running in a pod. But because you don't want, all of this stuff as well as your service, James, where's Gallery View? I don't think James is on the call. So James is developing a Kong plugin. So the general idea is you would start the Kong control plane, which I happen to have a Kong control plane running here. That's what these three are. And yeah, so I mean, the reason I needed that control plane was the Kong configuration talks to that control plane. So in a production setup, you would start the Kong control plane, and then you would go either via the Kong command line to the admin API, or if you're enterprise, probably via Kong admin, and you would enable a Kong mesh naming 2PD. So you would enable a Kong mesh plugin. That Kong mesh plugin uses a Kubernetes construct that I can't remember the name of right now. Well, it enables it such that the Kong mesh service and the IP tables, so this one, the proxy init service, get automatically injected in pods. You're muted, Judith.
So that will be a separate, like a separate tool, but it'll be enabled as a plugin, basically. It won't be something separate to Kong. You'll configure it as a plugin.
Yeah. Yep, it will not be separate to Kong. You won't need to modify your Kubernetes deployment YAML files. The plugin will handle it for you. I see Marco's here. Maybe Marco remembers the name of the Kubernetes construct. I can't remember.
It's not a custom resource definition. That's the only guess that I have on it.
Okay, well, somebody will follow up with that.
Yeah, we'll check on that. I think we recently added the ability to make some Kong nodes control planes and some data planes. Do you want to talk about what's going on there in a little bit more detail?
Do I want to talk about that?
Or if Aapo wants to talk about it, perhaps you would want to jump in.
So you can kind of see that here, where, so I don't want the Kong mesh to also be a Kong admin. So I don't want it to also have a control plane. So you can Kong admin listen off. And so just the Kong admin listener is just not turned on the Kong mesh instances.
Okay, so essentially, like, basically the admin port is disabled or something like that.
This is Marco here. Yeah, so basically by allowing a Kong process to enable or disable certain services, like the proxy functionality or the admin functionality, we can dedicate and allocate specific Kong nodes to a specific function. Effectively, we can have a cluster of Kong nodes, a set of Kong nodes that only have admin enabled, and those Kong nodes perhaps could be put in front of a private load balancer. And those Kong nodes will only be able to configure the system, but will not be able to execute API requests on the system. And the reason for that is that the proxy service will be disabled. So by separating the planes, we are effectively saying a set of Kong nodes can process API requests, and this other set of Kong nodes can only configure the system, but cannot process the API requests. So we're separating the concerns.
And do you have recommendations for securing those nodes, securing access to those nodes, or placing some behind a firewall or something like that?
That's correct. I mean, the data plane should, the Kong nodes that are executing the API requests, the proxying functionality, those Kong nodes should never have the admin functionality open, for the simple fact that the clients consuming APIs through Kong do not need that available in any possible scenario. So we can start a new set of Kong nodes that are only admin, no proxy, and those Kong nodes can be in a private subnet behind a private load balancer, where only people who really have to have access to them can access the nodes, right? So we are effectively segmenting how the Kong cluster is being deployed by having on one side those proxy nodes that anybody can consume, and on the other side, admin nodes that only admins can use.
Cool, that makes a lot of sense. Great, so Aapo, if you want to unmute, I think we're kind of gonna informally or maybe formally move into the Q&A portion of, oh, before we move on, Colin, did you have anything to add, or are you like set?
No, I'm good.
Awesome. Thank you so much for this demo. It was really cool.
Yep.
So Aapo, hi, I see you've unmuted. If anybody else has questions about any of the settings that Colin went through, now would be a great time to ask them, since we have both Aapo, Marco, Hisham, we've got everybody here. So feel free to unmute and ask away or chat. So if no one has a question, I have one, which is, I was wondering if you could talk a little bit about the details of that transparent configuration and what it's doing and how it's interacting with IP tables.
Yes, I can pick that. If you, Colin, want to stop sharing.
Yep, no problem. There you go.
Yeah, I can share mine. So, service mesh. This is more like what Colin just showed you, but this is more like how to do it manually without any Kubernetes tooling or integrations. This is kind of like lower level how it works. So what we added here in Kong 1.0, we added stream routing, which we didn't have before. Stream routing and stream proxying is layer 4 proxying, so it's raw TCP at the moment. Currently, we don't support UDP, but that might be added in the future. So at the moment, if you want to use Kong to proxy, let's say, gRPC traffic, you can use the L4 streams for that. In the future, I guess we will be adding a layer 7 support for gRPC as well, but that's in the future. I can quickly show, you asked about how IP tables go with all this. So there is a section, I think there was configuring transparent proxying rules. So this is what Colin script basically does, or similar to this. So we add like IP tables routing rules. On Mac, I think you can use or BSDs, you can use another, which is like which is PF or something like that rules. I can update this document later on to support those scenarios, but these are mostly on the Linux side right now. So for example, this rule here adds that if the destination port of this is the service A that tries to call the service B. If the service A tries to call the destination port this, we actually change the request transparently go to actually the sidecar node of the service A and on port 9000 on this example. And that's why we do have let's see, we do have a transparent option here. So this, when I start the service A sidecar proxy here, I said that I want to have a stream on 9000 and it uses transparent. Also, I do similar things for the HTTP and HTTPS here. So this example goes through all these different protocols. I also added like proxy bind setting here so that we can configure this so that in first example here, I just start service B, which is ncat, and then I start actually several versions of it. It's one for TCP, one for TLS, and then one for HTTP and one for HTTPS. So they are always on 5, but in different ports. Then I just connect them through with ncat, which is the service A. This step 2 is exactly the same as the step, the one that we use here. There's nothing different here, but with all these IP tables rules and transparent listening options, the request actually goes through 2 Kong nodes, which are the sidecars for service A and service B. Apart from that transparent option, we also have an origins option. Origins you can enable on certain nodes. This is node level configuration. So for example, if you want, you can do things like change the port. So origin actually, when we do the load balancing and it tries to proxy, because this node actually knows that it's servicing an service B, it can kind of like change the port to actually different. We can also do like HTTP to HTTPS upgrading and HTTPS to HTTP downgrading. Also works with TCP and TLS when you're doing with layer 4.
Are there other use cases aside from the service mesh use case where you need a Kong node to be able to recognize its service and send traffic onto it? Are there other use cases for setting origins in this way? Like, are there other reasons that somebody might want to do it, or is it basically just for service mesh?
I guess it's usable when you do have like a sidecar deployment. You don't need to have like a fully service mesh there, but you can use it even with just sidecar. But usually you get like most of the benefits when you actually deploy it fully on service mesh.
Great. I think this is great. I think were there any other settings that we added recently for service mesh that we wanted to go over? Do you know, Marco?
I guess we could look like a stream routing, which is a new thing.
That would be great.
Yeah. So let's quickly see those. So here I create routes and services. This is for TCP, and I create this normally like this. This is the one that's 5 is the service B, and it's listening TCP on 19,000. And I do set that as a service. I create a new service with upstream URL of this raw TCP straight to the service B on 19,000. Then I do create, this is the new thing. So I create a route for this service. And whenever there is a destination 5 and 19,000, I want it to go to service B, which is kind of like interesting because this is actually the same as this. But because all these IP tables transparent rules, it actually goes through the two Kong nodes, two sidecars. Yeah, and there are all other rules like you can route by protocol, and then you can add like different destination IPs, or you can even use subnet masks here, and then you can add ports. As you see, there is one. You can define multiple rules in one route. Right now, these L4 proxying rules like destination IP, destination port are only used for stream routing, but we are looking forward maybe to add a possibility to use those rules even on, let's say, layer 4 proxying routing like HTTP and HTTPS. But when we released this, we didn't want to change too much of normal routing rules of HTTP that we did before.
Cool. So that'll be like an incremental rollout type thing.
Sure. Was there something on your mind, Hisham, that you wanted to show, or have we covered most of it?
No, I think we covered most of it. I think it's a good roundup of the new settings.
Cool. So we've been having a little bit of a side conversation in chat about automatic sidecar injection in Kubernetes. And so I was wondering if we might want to just talk about how that works. That repo that just got posted in the chat, I'll put it into the notes, but I was wondering if somebody wanted to talk about how that works specifically.
I know how it's intended to work. I have not
Awesome.
actually used it myself personally.
That's great. Tell us all about it, Colin.
So its intention is, yeah, if you view it in chat, so instead of adding the Kong mesh and the Istio IP tables, the Istio, what is that container called?
The proxy init.
Yeah, the proxy init. So instead of doing that in your own deployment YAML, you do it as a sidecar injection, which means anytime you start a pod, those two get injected. So the proxy init as an init container, so it just runs once, kind of mangles IP table rules on your behalf, and then the Kong mesh node.
So does that work specifically only with Istio, or is that any like any Kubernetes cluster it would work?
So the Istio proxy init Docker container is actually not an Istio container. It's just a container that has an IP tables bash script to mangle the IP table rules such that it will proxy all traffic with the exception of one user ID. And so the goal of that is to funnel all traffic within the pod to Kong or Istio or Ambassador or so on and so forth. So a lot of other kind of mesh overlays tend to use the proxy init. You can find the proxy init bash on the Istio repository. And yeah, it just made sense to use someone else's prior art because it works, it's tested. Why reinvent that wheel?
Cool. And then if you're injecting a sidecar into every pod, does that act as service discovery? That kind of gives you your Kong cluster a sense of what's running in your Kubernetes cluster, or how does that work?
Does that act as service discovery? Not having tested this, my impression is that would effectively give you service discovery. It's kind of a half question because I'd like to try the sidecar injector myself. And I know the sidecar injector, it looks like it is a Kong plugin already, or it's going to be a Kong plugin. So.
Cool. Okay, well, we will maybe have a deeper look at that on a future call. Sounds like there's a lot going on in there. Cool. So does anyone else have any questions or topics of discussion? We are now to our open agenda portion. All right, great. So as I mentioned, next time we are going to have a community member talking about proxying mock APIs. If anybody else wants to get on the agenda, feel free to just add your name to the future topics section and I'll reach out to you and see what you want to talk about and get you on the schedule. So thanks so much for joining us, everybody, and have a great month. The next, let's see here. The next community call will be on February 12th, I believe. Let me just get this slide up so that I don't tell you something that's wrong. February 12th, there it is. Okay, so we will see you all on February 12th. Thanks so much for joining.
Thank you, everyone.
you. Bye.
Bye. And thanks, Colin, for presenting.